Hey, I'm Melissa.
I'm Jam.
I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Okay, Jam. Guess what we're doing today?
What are we doing?
We're doing a question and response episode.
Nice. It's been like, how many episodes ago we did the first time of that?
5, I think.
Okay.
So we're on
Sweet.
a nice 5. Oh, also, happy 10th anniversary. This is our 10th.
Yeah, 10 episodes.
Wow. Can you believe we made it?
Yeah, all the haters couldn't bring us down.
I don't think... I've only encountered encouragers, not haters, so far.
Yeah, that's true.
So we're going to do a Q&R. We've got some questions. We actually have not only questions, but some statements.
Whoa, statements.
Mm-hmm. Like a little bit of a corrections, maybe.
Oh, interesting.
Before we start that, I want to hear about your week.
Dude, yeah. Not a ton to say.
Any updates on your work life?
No updates.
Oh, I'm sorry. Maybe I should have screened that question before I asked it on air.
It's okay. No updates there, but I have been keeping busy with other projects, and one of those projects came to life this past week. It's a hat with a friend of mine, and we have been working on it for several months. It's a sort of political humor hat is the best category for it, I would say. And it's a thing we're selling. So we're selling this hat online. And so it's basically a parody of a pretty well-known political hat. But I won't say too much about it here. Don't want to get too into it. And definitely don't want anyone to be offended at all. But if you're interested in hearing more about it, you can find me on Instagram and you can see information about it or message me about it or whatever. So
Find you on Instagram where?
Well, on Instagram.
What's your handle?
Oh, I was like, on Instagram. That's fine. It's JamRBN. So just those 6 letters.
Okay.
JamRBN.
Nice. I'm a little offended because I was supposed to be in the advertisement for your product, but I was slighted and left out, and I'm pretty hurt, but I guess we're going to be able to move past it.
We were doing it and you were there, but then you asked if you could do it later.
Yeah,
Remember?
and then you said no when I asked about later.
We're doing
Don't let him talk you guys out of it. He slighted me. I was excluded from the project.
We're doing an ad, and the sooner we could get it out there, the sooner we can start selling these things, because we are eating the cost of having them exist at all right now. So yeah, we're doing an ad to try to get the word out about them. So
I guess I understand.
It's fun though. It's like fun to have projects like this.
Yeah,
this is
fun.
a really fun project, the podcast, doing these hats. And so it's been enjoyable to do that kind of stuff, and to see them actually come to life is pretty cool. So
yeah, it really is cool. I've had so much fun. And I did a little post about this on Twitter, but just seeing people get so excited about chemistry.
Yeah.
And I've heard some people will tell their friends and coworkers about it, and they're so excited to share about chemistry. It's just been so fun. And people writing in and asking me questions. And my friend Erica, who I haven't talked to in a while, reached out and said she was enjoying it. It's just been really fun to sort of, it's a fun way to get in touch with people again. And it's a fun way to share and do science communication. It's like my SciComm dreams are coming true. I'm having so much fun. Okay.
So what about your week?
Oh, I was going to skip that. I was so excited about the questions. My week has been good. I'm back in school. I got to collect some of the first data for my research. One of my students pointed out a way I could make it better, so that was kind of fun.
Nice.
I'm really enjoying my students this semester, and just things have been easy going, even keel. I've been able to see some cute babies recently.
Oh, nice.
My less than 1-year-old friend Odessa, my less than 1-year-old friend Miles, my 1-year-old nephew Edison. I have a really cute picture of him drinking out of a Dallas Stars cup. It's almost hockey season. Go Stars. So it's been good. I'm just enjoying life. Jam's beautiful wife brought me a Dr. Pepper.
Can you hear it? Can you hear the ice? There it is.
So yeah, I don't know. It's been good. It's been a really good week. I'm just like, living life. It's been good stuff. I'm pretty happy. I've gotten to see some good friends. Just,
yeah,
it's been good.
You know what to say about life?
No, I don't.
It's meant for living.
Oh, Yeah, so let's get into these questions and responses. I'm so excited.
Me too.
These have been coming in, and it's been fun to be like, oh, I don't know, or oh, I'm going to look into that. And we've got a few. There's two that we're not going to address today. One from Kurt D. About the origins of atoms.
Whoa.
We're saving that. We're putting it away. And I just got one. It's too many, but I just got one yesterday from Sam F. about what happens to eggs when they get hard boiled.
Whoa.
So
interesting.
It's fun because there are things that I wonder about on a day-to-day basis.
Yeah.
And I know that I wonder about them and I've solved them or I've looked into them or whatever, but it's fun to hear what other people are wondering about.
Yeah.
So I'm excited.
Dude, sweet. Okay. Yeah, I am too. It was fun doing the questions last time. So it makes sense to do it pretty frequently too, because if more questions build up between times we do it, then it makes it where people are wondering for a long time and they don't have any answers.
Yeah.
Or we'll just have too many before it becomes too hard to address all of them. So, okay. You ready?
I am ready.
So this first question is related to episode 2. It comes from Adam B. And he says, "Hey, Melissa, been enjoying your Chem for Your Life pod." He likes to abbreviate.
So do I.
May be similar to the specific heat episode, but as I sit here enjoying a bowl of ice cream with Magic Shell, I can't help but ponder the chem behind how Magic Shell hardens so quickly. What is Magic Shell? I don't know what this is.
Magic Shell, I can't believe you've never heard of Magic Shell.
Yeah, sorry.
Magic Shell is liquid syrup that when you put it on your ice cream, it instantly hardens.
Oh, interesting. So it's kind of like being able to have a dipped cone sort of deal at your house.
I think it's exactly like a dipped cone. I assume they use very similar things, but
Yeah.
So that's Magic Shell.
Nice.
Okay, so I wasn't sure at first the answer to this question, but I had an idea. I Googled to confirm my idea. Can you think of a household item that has the properties of being liquid at room temperature and then solid as it cools down? Long, thoughtful pause. Okay, I'll just tell you.
Okay.
Coconut oil.
Oh, yeah.
So you've seen it be melty and you've seen it be solid? Okay, well, so here's my suspicion, and I Googled to confirm that coconut oil was a base, and according to chowhound.com, that was true. Not a base. Coconut oil was a base of Magic Shell. Now that we had an acid base episode, I don't want to.
Oh, I see.
It was like a base element of that.
Okay.
And it seems that is correct. However, coconut oil doesn't exactly stay liquid at room temperature. Sometimes it can even harden up a little bit at room temperature, depending on what your house is at.
Yeah.
So my suspicion is, and this is where episode 8 is going to pull in here. Do you remember when we talked about how you add salt to water? It increases boiling point, but it also decreases the melting point.
Yes.
So I suspect that they made a solution wherein the cocoa or whatever was dissolved in the coconut oil and lowered the melting temperature. So it would be liquid at room temperature and solid as soon as it hit something slightly colder.
Nice. And ice cream or whatever is a lot more than slightly colder, especially at the very beginning. It's like a significant change.
The big deal would be making sure that it wasn't a liquid at normal room temperatures, like in people's houses who keep it at 65 or whatever. Yeah. That it doesn't become a brick. So that's my suspicion. The food industry keeps stuff under wraps pretty well. And so I haven't been able to confirm 100% what they do. They could also change the molecular structure and actually add in some double bonds or something to make that oil more liquidy at room temperature, which is episode 3.
Yeah.
But so it's hard to say 100% what they do, but they basically will take something like coconut oil that's close to the melting point they want and alter it just enough.
Interesting. I learned 2 things today. 1, what the heck Magic Shell is, because I'd never heard of it. 2, how it works.
Yeah, I can't believe you've never heard of it still. That is baffling to me.
Well, maybe I shouldn't know about that name. I don't know.
It was a staple of our childhood.
It doesn't sound like a food when I just hear those words, Magic Shell. It doesn't sound like a food. It sounds like a kid's toy or something like that.
Let's get some Magic Shell for you to eat, and we'll put that on the social medias.
I will eat it. I can promise that I will eat it.
Yeah, let's do it.
I can deliver on that.
I want to do it too, though. You don't eat it without me.
Okay. So the next question is regarding episode 3, and it comes from Autumn K. And the question is this: what causes the bonds to move in trans fats?
Autumn, that is a great question. And the answer to that question is to be continued. I didn't want to leave it sitting for too long. I think I heard a couple of people ask me that in real life too. Autumn actually wrote it in. So we have not ever, that I can remember, covered when in hydrogenation a double bond would move. That would require bonds breaking and reforming in ways that I'm not sure how it would switch from cis to trans or move between two different atoms without bonds physically breaking and reforming. And I've done a little bit of investigation on some journals. There's one really old paper that I couldn't get access to that might have explained it. And there's a lot of stuff, again, in the food industry that is hard to get information about unless you're in the food industry, or maybe I just haven't figured out how to break into that. So if there are any food chemists listening and you want to reach out and talk to me about things, I would love to learn about food chemistry. We had a little bit of food chemistry in college, but not very much.
Yeah.
So all that to say, I don't have the answer yet, but I am working on it. And also, I told you guys at the very beginning that just because I'm, quote, an expert, that doesn't mean I'm going to have all the answers. So this is one of those times.
Yeah. But that kind of makes it more cool, too, because it's like you are going to do some investigation on this. Like, we could all Google, too, but we wouldn't know if we're getting the right thing. You know?
Well, and
it's more sophisticated than just Googling. It's like, what a specific question. People are really more just asking on Google, like, what is chemistry? Or like where do I science? That's like kind of people's main questions. So
yeah, that is what's nice about Googling with a basis of knowledge is I can take things in and decide which ones are logical. That is probably right. Versus which ones are, that doesn't make any sense. That's total bogus science. And now you guys, with some of the knowledge that you're getting here in this podcast, have the ability to do that same thing. That's my hope anyway. And
you have the connections of a community of scientists that we don't have. So like,
yes,
like you mentioned before, you've been able to talk to some of your colleagues, so that's pretty cool.
Yeah.
Sweet. Moving on. The next question is regarding episode 6. It comes from Nikki N. And the question is this. I keep thinking of Ferd Hafley. And this next question is a question. And I will read it right now. I have a question about the boiling episode. So if the boiling point is lower, like in the higher altitude example, is the temperature of the boiling water cooler?
Yes. The answer to that question is yes. So if the boiling point is lower in the higher altitude example, it's boiling at lower temperatures. So the simple answer is yeah.
Yeah.
Boiling point is not fixed. The boiling points that you know and love are based on the standard of being at sea level. So it's not really fixed. It's just a standard that we're comfortable with.
And I only knew that from stories from my family about like following certain directions on certain recipes or whatever.
Yeah.
They just had to adjust stuff. Especially if something called for a specific temperature on something. Like some teas, call for like, hey, have it at the temperature. And they sometimes had to just do whatever they could because they couldn't get it quite hot enough.
Yeah. Well, and that's something that we sort of skipped over because you already knew that. And I was going to hit it harder in the episode,
That's
and
true.
then I didn't have to.
I totally cheated. I wasn't representing the every person.
No, because you had that connection. But
yeah.
So I'm glad she asked that so we could clarify. And I think that just goes to show there's a lot of things that seem like absolutes that aren't. So if someone asks you what the temperature of water boils at, you should say at which altitude. And then you seem smart. Or, I mean,
yeah.
So it really is not what is the boiling point of water is not one consistent answer.
He could also respond with like, at what altitude, or are you completely underwater at the bottom of the ocean or on land? Like we talked about someone doing that.
Or have you added a handful of salt? Because that really changes things.
Yeah. You can have all these qualifying questions now and come across like a total...
A total what, Jam?
I'm trying to censor myself.
Like a totally smart and pretentious person who thinks you're better than everyone else. Or you can do it in a fun way, like, oh my gosh, I learned so much about that. Did you know that water isn't actually a fixed boiling point?
Yeah.
Nothing is, and everyone will be excited.
That's true. Yeah, you could do it in a way that's not really like,
Or you could do it in the other way if you want. I'm no better than you.
For some reason, that's the way I assume people do it, but there's definitely like a very cool, like actually sharing knowledge with you kind of way of doing it. So
That's my whole goal in life, is to do it in a cool way and not a pretentious way. I've not always succeeded. Sometimes I do come across pretentiously. Okay.
This next question,
our listeners are getting to see a fun new side of us.
This next question is regarding episode 7, and it comes from Anthony C. Here it is. This is more a correction than a question. Oh, no. There are only 2 types of waves, transverse and longitudinal. Microwaves are a range of wavelengths.
Okay, so this is a good question, and I actually discussed a little bit more with Anthony C., and he then said, wait, maybe that's not exactly correct, or maybe it's based in disciplines. So I'm going to start by saying this. The different, quote, types of waves that I talked about are differentiated based on wavelength and frequency. That's true. So it's all like if you change the wavelength or frequency of a wave, you could get it into a different range that makes it a different type of wave.
So from like ultraviolet to
visible,
microwave to visible light kind of thing. Okay.
But chemists do colloquially call those types of waves. So
I see. So he's saying they're not types really. They're just different frequencies.
Yes. Okay. And so I'm not a physicist. And a physicist who's listening might be mad, and they might also know more about the different types of waves. Maybe it's not even just transverse and longitudinal. I don't know. But in chemistry, when we're talking about types of waves, we're talking about different wavelengths that fall into a range that have been distinguished by their properties. So microwaves, radio waves, visible waves, UV, infrared, all those things are distinguished based on their wavelengths and their frequencies. And so we've just sort of put them into groups, but it is all just a wave. And then the wavelengths and the frequencies are different. But a chemist I was talking to, I'm not sure if they want to be called out, so I'm not going to say their name, said, yeah, I would just call them types. This is why mathematicians and physicists don't like us, because we're not very precise. So I thought that was funny. And also just a confirmation. I thought, I've only ever heard these called types of waves. I don't think I've ever heard any distinction about that. And it's just because I'm a chemist. So, so I'll concede that is a correction. I'm not 100% sure what a physicist would refer to those as, but that's the chemist view.
I feel like you guys are actually precise, but just in different ways. Like you guys would be really precise in the measurement of something. We put in this many milliliters or whatever of this, or like...
Well, analytical chemists would. Yeah. Organic chemists are not so precise. So it even, breaks down within your discipline. Okay. All disciplines of chemistry are equally good and beautiful, but they are very different. And
that's so interesting.
Even within that, like chemists and physicists see things differently, and biologists are different. Scientists really do have different perspectives on the world.
Yeah. Okay, this next question is also regarding episode 7. It's basically the same question from 2 different people.
Okay.
I think the wording we have is from Jason C., who is my co-host on Podcast for Your Life.
Podcast for Your Life.
Hey, Jason. What's up, dude? And then also Nikki N., who asked a previous question, asked the same question pretty much. So the question is, do microwaves change the nutritional value of food? I've heard it said that microwaves kill some nutrients in the food you reheat.
This is a very broad question you're asking. I'm not a food chemist. I really should probably take a course. I've never been in a place that's offered one. I want to so badly. Yeah. But this is a very broad question. I don't even know what you mean by nutrients in some of these cases. Like, are we talking vitamins? Are you talking proteins? Are you talking carbohydrates? So what nutrients you're talking about, the way those interact with microwaves would be different. So we would need to clarify some of that. The biggest thing I can say is I think it's possible that there could be some bonds breaking, some proteins denatured, things like that could be happening when they're exposed to heat if they absorb the microwaves. But that would be true, I think, for being exposed to any kind of high heat can change the chemical makeup of your food. Yeah. So I'm not sure that microwaves are going to be any worse or better than any other type of cooking. They will change some of what's going on, but I don't think also they'll do it so significantly that it's not valuable to eat vegetables anymore.
So you're saying, like, so say I take some broccoli, if I cook it in the oven versus the microwave, maybe they'll taste pretty different, but they're both being exposed to heat. And so the effect, if there is any significant effect on its nutritional value, would probably most likely be similar.
Ooh, I think it'd be similar. It's not exactly the same because in the microwave, it's being exposed to a certain type of waves, which heat up the water molecules, which heats, a lot of the broccoli is high water content. In the oven, it's just being exposed to heat as a whole. So it's not just heating up the water content, it's heating up everything. So that's a little different. And the things that result on a chemical level will be different, but I don't think it would be so significantly different that one would have significantly more nutrients than the other.
Yeah.
Being ruined or whatever. I think it might be different ones, and that's kind of why you get a different flavor, but I'm not 100% sure on that. We do have a friend who's a nutritionist that I'd like to bring on, or barring that, I'd really like to get someone who has a background in food science to ask some of these questions because they're really good. But my opinion as a scientist, I could not find any really great information on this, is that likely they would not significantly damage the nutritional value of your food. And they would do so, all heat sources would do so in similar ways.
That's a huge relief to me, knowing that, like we established a couple of episodes ago in that microwave episode, how ramen noodles are really good for you. It's great to know that all that goodness is not being removed by the microwave. Like, it's still there.
Ramen noodles, we are not sponsored by ramen noodles, and I am not confident that what Jam is saying should be taken seriously.
It is just a huge relief, is what I'm saying.
Okay, so we did a quick break because I was thinking, I didn't really look into this much, and I'm wondering if the internet has anything to say, if I can sort quickly through and find some reputable sources. And there is a New York Times article that sort of affirms what I'm saying, but also says a little bit more. And so it says that this is a New York Times article called The Claim, Microwave Ovens Kill Nutrients in Food. Thank you, New York Times, for the work that you do. Everyone get a subscription. Okay.
And we will link to this article so that you can, we'll do it in the show notes. So that
that's a good
they
idea.
get the straight up source. But yes, go ahead. Sorry.
So it just says that in studies at Cornell, scientists found the effects of cooking water-soluble vitamins in vegetables and found that spinach retained nearly all of its folate when cooked in microwave, but lost 77% when cooked on a stove.
Interesting.
So, really... Oh, and then there's a little bit more that says if you add more water, then you can lose more nutrients because the nutrients are water soluble, so they'll leach out. But
unless you just drink the water.
The base, unless you
drink your spinach water,
Sick. Okay, so all that to say that all kinds of cooking putting heat into something will cause some reactions to take place, likely, and the microwave is not going to be any worse than anything else. In some cases, it might be better. And don't believe everything you hear.
I have a slight aside thing that's interesting that maybe we don't have to include.
I want to hear it.
Okay. I took a nutrition science class one time, and I was an undergrad non-science major, so it's not like the perfect, and this is my memory of it too, so it's not like it's great info. You could probably poke holes in it. But I read this book that was super interesting. It was like a optional reading, and I was like, heck yeah. And read this book called Fear of Food. We can also link to it in the show notes.
Okay.
And one of the things, basically, it's like all these stories of food trends that were pretty much wrong in some way through history.
Interesting.
And so it's not like it replaced them with all the perfect science. It was like, hey, here's something people thought for a long time. There's this guy who was the pioneer of cooking vegetables. And he just, for some reason, thought that vegetables weren't good for you unless you cooked them. Like, it was just like weird on the rise kind of thing where it was like, oh, cooking things like this is much more available to us now. And so he just thought inherently that meant that they were better because they're softer. He thought maybe your body could like get what you needed out of the vegetables a little bit easier. And so he would literally cook every single vegetable he ever ate and just thought that was the only way. And it started, and he was like an advocate for that. So it kind of started this trend of
I don't really eat vegetables that aren't cooked, so I'm fine with that.
Yeah. Well, I think it was just
but
interesting
apples, step off my raw apples. Those are the best.
I don't know if he did that for fruits. I'm not sure what he did for fruits, but
that is so interesting. That'll be a fun book.
Yeah, it's very cool. I had rented it. One of those regrets. I rented it, and I was like, man, I wish I could keep this book.
I want the audio book of that.
I bet it's out there. I mean, I don't know if I remember all those things, but it sounds like really good material to revisit. It's been 7 years ago that I read that. So
that's nice.
Okay, so that's all the like episode specific questions, but we have a fun one that I think was included by you.
I wanted to ask a fun question because I felt bad that I got all the questions and I get to do all the answering. So I wanted Jam to get to answer one. So here's my question for you, Jam. If anyone wants to send in some icebreakers for our next Q&A, we'll probably do one again in about 5 episodes. Then that would be really fun. We'd love to answer questions if you just want to hear from us. We'll put them at the end after the science stuff. But we also want to hear from your science questions. But
yes,
if you could have one liquid come out of each of your pointer fingers, so it could be the same, I guess, or different liquids, what would those liquids be? And you could have them forever. Psh, psh, no problems.
Okay, so the first one is super easy.
Okay.
It's coffee. I would want coffee.
But is it hot brewed coffee or cold brewed coffee? Like what flavor coffee would it be?
Well, for year-round use, because I'm mostly a hot coffee dude, except for whenever it's super stinking hot in Texas, I would prefer hot coffee to come out of one of them.
Do you think it would be boiling? Or like how hot do you think it'd be when it came out of your finger?
I would say 170 degrees would be perfect.
Do you think that would negatively affect your body at all? Or does it heat up as it's leaving your finger?
Let's go with that. Can I? May I?
Sure, I guess.
I mean, I think right at drinking temperature would be perfect because, like,
somebody used gasoline once and we were like, will that give you cancer?
Yeah.
It was on the show that I'm not a part of, but I feel like they're my friends because I listen so much.
I brew coffee at 200 degrees, but you don't really drink it at that. You usually drink it at about 150 or something like that. I don't know.
Nice.
So that'd be the first one. The second one's really tough. I thought about a few things already. Like one, I could do some sort of cleaning product out of that one because it'd be kind of nice and really, really awesome to have that on hand whenever you want. But I'm also like, well, I don't know. It's not like I'm always cleaning, but I am at least 3 times a day trying to eat something. And so I feel like if I could have Soylent come out of my right pointer finger, then I'd be totally set up. Got the drink I want, got the food drink that I want.
Talk about mixed feelings.
Yeah.
Jam doesn't like probably one of my favorite podcasts, My Favorite Murder, and I don't like Jam's life source, which is Soylent.
Yeah.
Can you explain to the listeners what Soylent is?
Soylent is a meal replacement drink that is built specifically to be exactly 20% of everything you need of a 2,000 calorie diet. So that's not everybody, but it's exactly 20% of that. So all the vitamins that are recommended for that, and also like amount of carbs and protein and all that stuff. So it's just a little modular bottle of 20% of what you need. And I drink it twice a day, every weekday.
And I don't like it because it sounds like soil it. Like Soylent is going to make you soil your pants is what I think every single time I hear it. I hope we don't get sued for slander. I've heard it's great and delicious. I'm just not interested in eating something that sounds like soiling.
Yeah. Hey. I mean, they did take their name from like an old sci-fi movie, so I think they're willing to embrace whatever. They're just kind of like, hey, we're doing our thing. We're nerds.
That's a useful piece of information about you. Now people get to hear from you, not just me.
So Melissa and I have a lot of ideas for topics of chemistry in everyday life, but want to hear from you, just like we have for this episode. If you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, FOR, Your Life, to share your thoughts and ideas. And if you enjoy this podcast, you can subscribe on your favorite podcast app. If you really like it, you can write us a review and rate us on Apple Podcasts, which really helps us to be able to share the podcast with even more people.
We want to thank you guys so much for listening. And actually, we're going to do some shout outs. There are some countries who have jumped significantly in the last week in numbers of downloads. So we're just going to shout out those countries because way to go.
Yeah.
So this is outside of the States. This is in other countries besides where we're located. So we'd like to give a big shout out to Canada, who had an enormous jump of about 40 downloads over the last week. Go Canada. I love you. That's where I want to be. We want to shout out the United Kingdom. They have they've jumped about 25. Way to go, United Kingdom. Germany jumped quite a bit, around 20 as well. And the Czech Republic, which is fun, they jumped about 20.
Whoa, sweet.
So
nice.
That's been fun to watch you guys in those countries get excited and maybe are sharing with your friends. It's just been really enjoyable to see those go up and imagine what's happening.
Kind of mind blowing. It's really cool.
It's really fun, and we're really excited. We're so glad that you're listening, and we want to shout out some new countries. One is Brunei or Brunei. We Googled how to say it so that we could be respectful. And
neither of us had ever heard of it before.
No,
not even once. And I'm like, kind of love geography, and I had never heard of it.
Yeah, I had to hand draw a map of the world, and I do not recall that country when I was in junior high. But I'm going to go back and look at the map I drew to see if it was there.
Yeah,
and Nicaragua, that's a new one, and Argentina. My sister studied in Argentina.
Nice.
So thank you guys so much for listening in those countries. We've had so much fun watching you color the map in and thinking about you there and learning about where countries are. I've had so much fun. So
and say hello to us on Facebook, Twitter, or Instagram.
Yeah, reach out to us.
Or email.
But we just wanted to thank you all for listening and for wanting to learn about chemistry and for getting excited about it with us, because it's been a really enjoyable time so far. This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam is our producer, and we'd like to give a special thanks to A. Kiwasong, who reviewed this episode.